Hi everyone! Welcome to the first episode of our channel. Today, we will be featuring 3 gas laws, namely Boyle, Charles, and Gay-Lussac, with the help of our fellow professionals. So, what are you waiting for? Let's get started! But before everything else, we'll first start with the important definition of terms for this topic. Pressure is force per unit area, calculated by dividing the force by the area on which the force acts. The Earth's gravity acts on air molecules to create a force, that of the air pushing on the Earth. Volume, the amount of space that a substance or object occupies or that is enclosed within a container, especially when free. Temperature is a physical quantity expressing hot and cold. It is measured with a thermometer calibrated in one or more temperature scales. The most commonly used scales are the Celsius scale, Fahrenheit scale, and the Kelvin scale. So, what are gas laws?
Gas laws are simply the relationship between volume, temperature, and pressure, which can be explained by using the combined gas law formula, which is PV over T equals K, where P is for pressure, V is for volume, and T is for temperature, and K is a constant number.
Combined gas law can be simplified with the 3 main gas laws, namely Boyle's, Charles, and Gay-Lussac, having one variable in each. To further explain, let us discuss them one by one. The first one would be Boyle's law. Boyle's describes how the pressure of a gas tends to increase as the volume of the container decreases, which is formulated by physicist Robert Boyle in 1662. It can be shown in the formula of PV equals K or P1V1 equals P2V2, having the pressure of the gas inversely proportional with its volume. We must remember the following important conversion factors. 1 atm equals 760 mmHg or 101,325 pascals. The marshmallow syringe experiment perfectly shows an actual example of Boyle's law because the volume of the marshmallow increases as the pressure inside the syringe decreases and vice versa. Now let us begin. We must first find the given values in the problem. Words such as initial and final give us clues to the value we are finding. Next is to derive a proper formula for the missing value. After the formula is derived, we just need to simply substitute the value and calculate the answer. The balloon popped in this equation because its volume increased too much that its container can't handle. Same goes for this next problem. Since it is Boyle's law, we can expect an increase in volume as it goes into standard pressure. Notice that we can observe the relationship between variables in answering the question. Charles' law is an experimental gas law that describes how gases tend to expand when heated, formulated in 1780 by Jacques Charles. It can be described in the formula V divided by T equals K or V1 over T1 equals V2 over T2, where the volume of the gas is directly proportional to temperature. 273.15 K is equal to 0 Celsius. It is always added to the present value of Celsius to get the temperature in Kelvin. Take note of the current size of the balloon. Then we will place it inside a freezer. Earlier we placed the balloon inside the freezer. Let us now check what happened to the balloon. We can see that the balloon shrunk in size. This can be explained by the Charles law, as Charles' law states that whenever the temperature is decreased, the volume also decreases. We must always remember to convert the Celsius to Kelvin for temperature. Like the process we did earlier, we must first list the given values and derive the formula. We can expect the answer of initial volume is more than the final volume since its temperature is higher. For question 2, the 5-liter volume has a 30 degrees Celsius temperature. Since temperature is increased to 40 degrees, we can expect the final volume to increase since V and T are directly proportional to each other. The final answer is 5.1 or 5 liters. Lastly, Gay-Lussac's law. As said earlier, we should remember that 0 Celsius equals 273.15 Kelvin. Joseph Louis Gay-Lussac formulated the law in the formula of P1 over T1 equals K or P1 over T1 equals P2 over T2, where the pressure of the gas is directly proportional with temperature. For this experiment, the soda can is crushed because of the difference in the inside and outside pressure of the can, caused by the rapid change in temperature from being heated to being submerged in cold iced water. For Gay-Lussac's law, an initial pressure of 6 atm and temperature of 25 degrees Celsius in the morning increased to 35 degrees Celsius in the afternoon. We can expect the value of final pressure to be more than the initial since it has a higher temperature. Next, the initial temperature is asked. List the given and derive the formula for the problem to be solved. The final temperature must also be answered in Kelvin. We can disregard the volume of gas since it's held constant. Well, that's it for the gas laws. Let us now do a recap of what we've learned. First, Boyle's. Boyle's is the indirectly proportional relationship between volume and pressure. Next, Charles. Charles is the directly proportional relationship between volume and temperature. And lastly, Gay-Lussac's, which is the directly proportional relationship between temperature and pressure. These gas laws are essential in our everyday lives. For example, the danger faced by the divers, the pressure inside the tires of the cars, and the inflation of objects. Studying these gas laws are a big help in our everyday lives, for we will know the relationship between different things in our lives. Boyle's law includes the bends. The sudden depth pressurization in the diver's body during a quick ascent makes the gases in his body expand that causes the breaking of joints. Another would be the bouncing of a basketball. The decrease in volume but increase in pressure when it hits the ground causes it to spring back or to bounce. Charles' law, on the other hand, includes the inflation of objects due to the increase of temperature. It can be observed in the expansion of pool floaters as the temperature increases due to the sun's heat. Another example would be the deflation of balloons if they are suddenly exposed in a place with low temperature. For Gay-Lussac's law, the firing of a bullet where the extreme temperature produced by the burning of the gunpowder creates a strong pressure that launches the bullet. Another example would be the explosion of tires due to the increase of pressure created by the frictional heat or the burning of the tire. That's it! Tune in on our next video. Please don't forget to like and subscribe and comment down below on what suggestions you have to be featured next on our channel. Thank you and have a good day!